what is the answer to that question, and then let us see whether your answer was correct or not. So the question was like this. All rods are of length L and mass M, and axis was actually the perpendicular axis. Axis is inside into the plane. Into or outward, both are the same thing. Now pay attention. Pay attention. If you see any of the part and this or this or this or this, these all are identical. These all are identical with respect to axis. So I system is equal to 4. 4 why? Because we have 4 such pieces into I of 1. I of 1. Alright. So that's what we are going to find out. Now listen to this. What is I of 1? So I1 is nothing but, let me tell you this also, moment of inertia of this, which is a rod. So it will be ml square by 3 plus moment of inertia of other part. What is other part? Other part is this. Now to calculate or how to count that, that is also easy. That is also easy. It's not modifying it. Anyways, leave it. So moment of inertia of that will be, pay attention, moment of inertia of this rod about the midpoint. Correct? About the midpoint, it will be how much? ml square by 12, because that will be the center of mass of that point. That will be the center of mass of that point plus this distance m into x square. M into x square. Okay. Now, how much is value of this x? So x square, basically it will act as diagonal, or you can say hypotenuse. So x square is equal to L square plus L by 2 whole square. X square is equal to L square plus L by 2 whole square, and that is L square plus L square by 4. So 5L square by 4. That is value of x square. We need x square directly, so we are going to put its value. So the final thing comes out to be I1 is ml square by 3 plus ml square by 12 plus 5ml square by 4. Okay. Okay. Any doubt, any question, anyone? Any doubt, any question, anyone? So that is ml square in the bracket 1 by 3 plus 1 by 12 plus 1 by 4. So ml square, LCM I'll take 12. So this will be 4 times plus this will be 1 time plus this will be 3 times. Okay. So that comes out to be 8 ml square by 12. So basically 2 by 3 ml square. So this is I1. So I system will be I system will be 4 times I1 is equal to 4 into 2 by 3 ml square, and that will be 8 ml square by 3. Answer. How many of you got the correct answer? This is the answer. How many of you had got the correct answer? Tell me. Rishikesh is saying, sir, it should be 5 by 4. Which should be 5 by 4? Which should be 5 by 4, Rishikesh? After taking common, how? 1 by 3 plus 1 by 12 plus, okay, it is 5 by 4. Just a second. Yeah. It is 5 by 4. Just a second. It is 5 by 4. I have written it 1 by 4. That was a typing mistake. So, this will be 5 into 3, 15. So, 15 plus 5 will be 20. So, so basically 20 by 12 ml square. Okay, 20 by 12 means 5 by 3. So 5 by 3 ml square, and 5 into 4 will be, this is 5 by 3. So 5 into 4 is 20 by 3 ml square by 3. Okay. You were talking about this, Rishikesh? Okay. So it should be 20 ml square by 3. Everyone please take note and correct this also. All of you please check the calculation once again. There could be any error also. Please check it. In fact, please check method also. If you are not satisfied, please feel free to discuss, argue, debate. No problem. Please. So how many of you got this answer? 20 ml square by 3. How many of you got the same answer? Okay. Nobody has said anything. Let me move forward. This is basically there are rods. M are solid sphere. M, or let me call it M1 R1 hollow sphere. I'm calling M1 R1 and M2 R2 so that you know, okay, who is contributing how much. And this is ML and this is ML. So basically we have two rods of length L each and mass M each. Then there is axis, and then there are, on one side there is a solid sphere, and on another side there is a hollow sphere. Solid sphere means that must be filled with mass inside also. Hollow means that will be empty from inside. Okay, so please solve and give me the answer. Give me the answer, everyone, quickly. Are you not able to solve, anyone? Okay, everyone, please pay attention. I can't waste time like this much. So first of all, we have four segments here. One is this, second is this, third is this, and fourth is this. So let us talk about each part one by one. So I system is equal to I1 plus I2 plus I3 plus I4. Okay. So these are the four parts for which we need to find moment of inertia. Now I1 means what? Moment of inertia of rod. I1 is basically this part. So moment of inertia of this rod about the given axis. So I am writing I1 is equal to ml square by 3. I hope you all are agreeing with me. Yes or no? I1 is ml square by 3. Do you agree with this? I1 is ml square by 3. Do you agree with this? Okay, only one person is agreeing. Okay, two more. Mm-hmm. Rest are there in the meeting? Amal is also agreeing. Sanya is agreeing. Okay. All of you, please mark your attendance by writing your name in the chat box. Please mark your attendance by writing your name in the chat box. Everyone, quickly, quickly. I2 will also be ml square by 3. I2 will also be ml square by 3. Now comes I3. Pay attention, everyone. I3 is basically moment of inertia of this solid sphere about the diameter which I have drawn. Okay, so I3 will be 2 by 5 mr square. Okay, this is moment of inertia of any solid sphere about its diameter. Plus, we need to apply parallel axis theorem. So plus, acha, mass of this is m2 into r2 square plus m2 into l square. So this is I3. This is I3. Now let's talk about I4. I4 means moment of inertia of this sphere about this, and then we have to shift it because we want to find about the given axis. So that will be 2 by 3 m1 r1 square plus m1 into l square. So these are moment of inertias of all objects 1, 2, 3 and 4 about the given axis which we are trying to calculate. So let us put all these values in this. So that will be ml square by 3 plus ml square by 3 plus 2 by 5 m2 r2 square plus m2 l square plus 2 by 3 m1 r1 square plus m1 l square. Please note, everyone. Please note. Please note. Please note. Any doubt, any question? Any doubt, any question? All right. All right. So I hope you would have understood now. Let me move further. Next question. So this is the axis. This is ML, 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 ML. This is M1, or let's take mass as M and radius as R, and this is hollow sphere obviously, and this is MR solid sphere obviously. Find MOI of system about the given axis. Please find, everyone. Quickly find and give me the answer. Quickly find and give me the answer. And this axis is in the plane. Axis is in the plane of rods, because spheres won't be having any plane. Sakshi is saying 20 ml square by 3 plus 16 mr square by 15. She is saying that. Hmm. Hmm. All right. One more answer and then I'll discuss. Quickly give answers, everyone. One more answers or 30 seconds, whichever completes earlier. Okay, everyone, please pay attention. I axis. Now let me define. This is 1, this is 2, mm, mm, this is 3, this is 4, this is 5, and this is 6. So I axis will be consisting of I1 plus I2 plus I3 plus I4 plus I4 plus I5 6. I said like that. I1 plus I2 plus I3 plus I4 plus I5 plus I6. How much is I1? I1 means ml square by 3 because moment of inertia of a rod about an axis passing through its end is ml square by 3, and that will be same as I2. So I am not going to write it separately. All right. Now how much is moment of inertia of this rod about the given axis? So that will be, if you see all the particles on this rod, they remain at distance of L. So I3 will be m into L square, m into L square, and same will be I4. Same will be I4 because both are identical. Both are both rods are identical. Correct. Now let us talk about I5. Let us talk about I5. So if we talk about I5, then moment of inertia of this hollow sphere about the given this axis will be 2 by 3 mr square plus how much is distance from the axis, that is L, so ml square. This is I5. Okay. I6 is equal to, this is solid sphere, no, this is hollow. Anyways, so let me write it as 2 by 5 because that solid sphere was solid. So this one will be 2 by 3 mr square because this is hollow plus ml square. If you notice, we have talked about I1, I2, I3, I4, I5, I6. We have talked about I1, I2, I3, I4, I5, I6. If we continue, then we will reach to I12 also. And if we go further, it can be I12 Pro also. So we can launch all iPhones here. Okay, very nice. So the point to be noted is moment of inertia of each and every object is to be calculated individually about the given axis, and when you have calculated with respect to the given axis, then later you can add them just like that simply. Why? Because MOI can be added or subtracted if they are calculated about the same axis. All right. Now there is a question from Mr. Yash. Yash is saying, sir, shouldn't be I3 be ml square by 12 plus? No. Reason is both are in same plane. Yes, try to understand. Both are in same plane. So when both are in same plane, axis as well as the object, then what you need to do is, if you see any mass on the rod is at same distance L from the axis, and when distance is same, then moment of inertia of any part will be mass of that small part into L square, plus for next particle mass of that part into L square, and that continues. So for the whole thing it will be ml square. Okay. Okay. If you are taking ml square by 12, you are calculating moment of inertia of rod about an axis passing through the midpoint and perpendicular to it. We want moment of inertia about an axis which is parallel to the rod, not perpendicular to the rod. Are you getting the difference? Yes. Parallel to rod, perpendicular to rod. Yes. Yes. The thing ml square by 12 is used to calculate moment of inertia of a rod about an axis passing through its midpoint and perpendicular to it. Okay, ml square by 12 is moment of inertia of a uniform rod passing through its midpoint and perpendicular to it. Okay, if you draw that line which is passing through the midpoint and perpendicular to it, then will that line be parallel to the given axis? No. So how you are applying parallel axis theorem? How you are applying parallel axis theorem in your solution? Understood? So let me put values in I axis. So that will be ml square by 3 plus ml square by 3 plus 2 by 5 mr square plus ml square plus 2 by 3 mr square plus ml square. So that gives us, let me take ml square common, 1 by 3 plus 1 by 3 plus 1 plus 1. 1 by 3 plus 1 by 3 is 2 by 3. 1 plus 1 is 2 plus mr square common. In fact, 2 can also be taken as common. 1 by 5 plus 1 by 3. And that comes out to be 3 into 2, 8 by 3 ml square plus 1 by 5 plus 1 by 3. So that will be 3 plus 5, 8 by 15. 8 into 5 will be 16 by 15 m r square. This is the answer. This is the answer. This is the answer. This is the answer. How many of you are getting this? How many of you are getting this? Please check whether I have done any calculation mistake. You are free to do so. I did not add I3 and I4. Just a second. Yes, you are right. Let me check. Okay. Let me name it. This is 1. This is I1. This is 2. This is I2. Okay. So you are saying ml square plus ml square. Yes, you are right. So let me directly add 2 ml square. 2 ml square. So if I add that 2 ml square, that means, so this will be 2, and that means 4 into 2. So this will be how much? Final answer will be how much? 14 by 3 ml square. It will be 14 by 3. Okay. Right. Thank you. Everyone, please check once again if I have skipped anything. Okay. Noted, everyone. Yes, she's saying, sir, why we did, sir, why? Okay. Why we did it differently in first question? Because which first question you are talking? This one you are talking, yes? Two spheres, one hollow, one solid. Because it was perpendicular to the plane. You don't read the question. Read the question. The axis was given perpendicular to the plane. Read the question. In the question, it was clearly mentioned that the axis is perpendicular to the plane. Hmm. Next question. After 24 hours of giving the question, you didn't even read the question properly. That's sad and bad, both. Pay attention, everyone. Hmm. So basically, this is a solid sphere. I'm trying to increase its size. Let it be. So this is a solid sphere, and it is in such a way that this is x-axis, this is y-axis, and this is touching. Solid sphere is touching. Inside one is also touching. Keep this thing in mind. In the diagram, it is not that visible. It is touching. So this solid sphere has mass capital M. Whole complete one has mass capital M and R. And from that, this portion is removed. Okay. So let me now write the question. From a given solid sphere, capital M R, a smaller sphere or spherical mass has been removed as shown. Has been removed as shown. Find MOI of remaining mass. Find MOI of remaining mass with respect to number 1 x-axis, number 2 y-axis, and number 3 z-axis. Okay, please solve everyone and give me the answer. And remember that as I told you, this is actually touching. Yeah, now it is perfect. Okay, so it is touching. Please solve quickly. It's a good question. If you solve this, your brain will be fully utilized. Fully. Okay, everyone. I waited for so long, but nobody answered. Pay attention and listen carefully. I'm talking about x-axis. Okay, about x-axis. So what you can see is I complete is equal to I removed plus I left. Okay, I complete is equal to I removed plus I left. Is there any doubt about this? Okay. Now, how much is value of I complete? So let me write it here very simply. I complete is nothing but 2 by 5 because it is solid sphere into capital M into capital R square. Okay. I complete is nothing but 2 by 5 capital M R square. Okay. Now, suppose M1 is mass of the remove. Uh, Hello. Can you see the screen? Can you see the screen, everyone?
Yes, sir.
All right. So I complete is 2 by 5 mr square. There is no doubt about it, right? Now, if M2 is the mass of the removed part, so how much will be I removed? Pay attention. I removed will be 2 by 5 into M2 into R by 2 whole square. Are you getting it? Because this whole thing is R. So half of that will be R by 2. Half of that will be R by 2. Correct? So now how much is M2? Let us see that. Pay attention, everyone. This capital M is nothing but 4 by 3 pi capital R cube into rho. Correct? Because mass is equal to density into volume. So rho comes out to be 3m upon 4 pi R cube. Okay. That is density of the complete sphere. So if we use that density to find out the value of M2, so M2 will be nothing but volume of the smaller part. So that will be 4 by 3 into pi into R by 2 cube into rho. Okay. So if you are going to put all these values, you are going to get M2 as M by 8. Okay. You are going to get M2 as M by 8. So I am putting the value 2 by 5 into capital M by 8 into R square by 4. So this is the value of I removed. So let us put all these values in this equation. So this is 1, this is 2, and this is 3. Okay, 1, 2, and 3. So now I complete. I complete was how much? 2 by 5 mr square. Let me put that. So 2 by 5 capital M R square is equal to I left plus I removed is Let me write it in this term only. So 8 into 4 is, or 2 into this, 8 into 2 is 16, into 5 is 80. So capital M R square by 80. So I left comes out to be 2 by 5 capital M R square minus M R square by 80. All right. So capital M R square is taken as common. 2 by 5 minus 1 by 80. Okay. So if you take LCM, this will be 80. And if it is 80, so this will be 32 minus 1, and this is MR square. So basically that will come out to be 31 MR square by 8. And this is I left. And we are talking about which axis? X axis. So this is the answer. This is the answer. Please note everyone, please note. Today, please note. Noted. Now, would you like to solve for rest of the cases? Okay. And let me solve it. How to use, I want to cut this diagram. Only one part is going. No, it should be the. Pay attention, everyone. Now we are going to talk about y-axis. I have decided to solve this because of a reason. You will realize once I'll complete it. Y. Same story about y-axis. About y-axis. So I complete is equal to I left plus I removed. Okay. I complete, we all know. How much was that? 2 by 5 capital MR square. Yes or no? Okay. I removed. This part is interesting and you need to pay attention to that. Everyone, please pay attention. When you are finding I removed, basically you are finding it about this axis. So about this axis, which I have drawn by red, is 2 by 5 into m by 8 into r by 2 square. This is what we calculated. This is what we calculated. This is but about this axis. But we need to shift it. So that will be plus m by 8 into r by 2 square. Okay, so basically that will total will become 7 by 5 into m by 8 into r square by 4. And this become 8 into 4 is 32 into 5 160. So 7 mr square by 160. That is I removed. Now let me put all these values in equation 1. So 2 by 5 mr square is equal to I left plus 7 by 160 mr square. Okay, so I left is how much? I am taking mr square as common. 2 by 5 minus 7 by 160. Okay, okay. So that will be mr square is anyway outside. 160 is taken as LCM. So when you have taken 160 as LCM, 32 into 2 will be 64 minus 7. So that will be भाइयों और बहनों 57 mr square upon 160, and that is I left. That is the answer. Sakshi ji, that is the answer. Two people who did not solve themselves, they went and liked your answer. Who did not solve themselves. उनको लगा कि कुछ तो बड़ा बड़ा सा लिखा है. This will be correct one. आलसी लोग. Check whether I have made some mistake or not, Sakshi. The rest of the people also please check whether I have made some mistake or not. I took m instead of m by 8. Savdhani, hati, durghatna ghati. Now I want all of you to calculate it for z axis. To calculate it for z axis. I want all of you to calculate it for z axis. Please calculate quickly. Give me the answer. This is for x-axis, Rishikesh. This is for x-axis. Sakshi, give your answer for z-axis. Give your answer for z-axis. Hmm. Hmm. Okay, let me ask you a question. Can you please explain how your answer of y-axis and z-axis are coming out to be different? For a solid sphere, y-axis and z-axis will be similar as far as we are calculating moment of inertia. As far as moment of inertia is concerned, to calculate the moment of inertia, x-axis, no, not x-axis, y-axis and z-axis will behave similarly. So moment of inertia about y-axis and moment of inertia about z-axis will be the same. Moment of inertia about y-axis and moment of inertia about z-axis will be same. Think yourself. Think yourself and see whether you are able to realize it that both are same or not. Are you able to realize that both are same? Everyone? Imagine a solid sphere. Now y-axis is the tangential axis. Y-axis is the tangential axis. It is not passing the hollow sphere. Correct? Z-axis is also the tangential axis. It is not passing through the hollow sphere. So basically both y and z are tangential to the hollow sphere. And if both are tangential, that means both will behave same. Both will behave same. Yes or no? So the behavior is similar for y-axis as well as for z-axis. Are you getting it, everyone? Because your steps will be same. If you are talking about z-axis, I about z-axis, let me write it. So I am going to replace y by z. So I complete is equal to I left plus I remove. Complete will be same 2 by 5 mr square, right? Okay. I removed will be how much? So for any diametric axis, for removed part, it will be 2 by 5 mr square. Plus you need to shift it to the parallel axis. And shifting will be how much? Same. M by 8 into R by 2 square. M by 8 into r by 2 square. So shifting is also the same value. And if you are going to put all these values in the formula, you will be getting exactly same calculation. You are going to get exactly same calculation. Yes or no? Yes or no? Are you getting it, everyone? I want you to solve this question once again as homework. Okay? Solve this question in homework. Yash is saying, sir, what about I x-axis plus I y-axis is equal to I z-axis? Very nice, yes. I would, propose a round of applause for you because you applied a theorem which is applicable for planar object on a 3D object, right? A theorem which is applicable only for planar objects, you have applied that theorem for 3D object. Very nice. Okay, let us move further. Let me give you another question. This mhm, yeah. So in this question, we have a disk. Okay. So this is a disk and this is x-axis. This is y-axis. Capital M R. This is removed. Okay. So question is find My of remaining part. Find MO of remaining part about number one x-axis, number two y-axis, number three z-axis. Okay. X and y-axis are in the plane of object. X and y-axis are in the plane of object. Mind it. And if you want, I can quickly solve this for your benefit. At least one part. Which part you want me to solve? Quickly tell me. Which part you want me to solve? X-axis or y-axis? Tell me quickly. Which part you want me to solve? Okay, Yash is saying z-axis. All right, Yash. As per your instruction. So about z-axis, I'm solving it quickly because we have lesser time. About z-axis, we are going to do the same thing. I complete is equal to I left plus I removed. Okay. Mass of the complete is capital M and this I am considering as M1. So I complete about z-axis. If you remember, for a disk, Moment of inertia about an axis perpendicular to its plane and passing through the center is mr square by 2. So I complete will be capital M r square by 2. All right. Now I of removed part, so I removed will be nothing but m1 into r by 2 square by 2 plus m1 into r by 2 whole square. So basically that will be 3 by 2 m1 into r by 2 whole square. So basically it can be written as r square by 4. R square by 4. Now the question arises is that how much is m1? How much is m1? So pay attention. In pi r square area, mass is capital M. So sigma, which can be called as mass per unit area, will be m upon pi r square. So m1 will be sigma into pi r by 2 whole square. So that will be m by 4. This was the most crucial step in this question. So I removed comes out to be 3 by 2 into capital M by 4 into r square by 4. So that can be written as 3mr square upon 16 into 232. So let us put these values in the first equation. So I complete was how much? Mr square by 2 is equal to I left plus I removed, that is 3mr square by 30. So I left will be mr square by 2 minus 3mr square by 32. Okay. So that comes out to be mr square by 2 1 minus 3 upon 16. Okay, I have taken 2 common outside. So that will be 16 minus 3 is 13 by 16. So 13 mr square upon 32. I left. Please check the calculation, everyone. Please check the calculation and see whether it is correct or not. Okay, please check the calculation. Please check the calculation, everyone. So have I done the calculations correctly? Sakshi, have you checked calculations? Have you checked the calculation, anyone? Have you checked the calculation, anyone? Okay, I am giving you time to check these calculations and solve the remaining two parts about x-axis and y-axis. Though there are very less chances of any calculation mistake in this. Yet, if you find any, we are ready to discuss. All right. So we'll be studying further in the next class. All right. Keep studying, keep solving questions.